So this time we're taking a look at section 7.5. And 7.5 deals with using the quadratic formula to solve quadratic equations. And so, if we want to solve ax squared plus bx plus c equals 0, we may use the quadratic formula. Quadratic formula is given as follows. X is equal to negative b plus or minus square root of b squared minus 4ac, all divided by 2a. Now, the a's that you see in here correspond to the coefficient of x squared, the b's correspond to the coefficient of x, and the c corresponds to the constant term. You want to make sure that your equation is in this form if you're going to use the quadratic formula. Now, I'm not going to derive the quadratic formula, but I do plan on showing you a few examples in which we use this formula to solve an equation, a quadratic equation. So, in this first example, we're going to solve x squared minus 6x plus 8 is equal to 0. Now, you might look at this and say, we really don't need to use the quadratic formula to solve this because we can always factor that left side and then set each factor equal to 0 and solve for x. But the quadratic formula is another method that we can use. And so, in this particular case, we would have a is our coefficient of x squared. A would be 1. B is the coefficient of x, which is negative 6. And then c is the constant, which is 8. Keep in mind, this equation is in the form we're looking for. It does have the form ax squared plus bx plus c equals 0. And so we would use the quadratic formula. And then we would plug in the values of a, b, and c in the appropriate spots of the formula. So here, we would have x equals, we have negative b, that's negative 6, plus or minus square root of b squared. Well, b is negative 6. Now, make sure you put the negative 6 in parentheses when you square it. And then we'll have minus 4 times a, which is 1, times c, which is 8. And this whole thing is over 2 times a, or 2 times 1. Now, it definitely looks like a mess, but this is a mess that's going to clean up very well, because what's going to happen is we're going to get x equals minus a negative 6 is 6, plus or minus square root of, square the negative 6, it gives you 36. We have minus 4 times 1 times 8. Well, 4 times 1 gives you 4, times 8 gives you 32. Let's subtract it away. And on the bottom you have 2 times 1, which is 2. Now, the 36 minus 32 is 4. And so we have x is 6 plus or minus square root of 4 divided by 2. But we know the square root of 4 is 2. And so that means that you have x is equal to 6 plus or minus 2 divided by 2. Now, this actually represents two different answers. 6 plus 2 over 2 and 6 minus 2 over 2. So we'll take a look at each. If you take a look at 6 plus 2 over 2, 6 plus 2 gives you 8. And then 8 over 2, same thing as 4. So 4 is one of our answers. And then we have x equals 6 minus 2 over 2. Now the 6 minus 2 gives you 4. And you divide that by 2 and you get 2. So x equals 4 and x equals 2 are our two answers to our two solutions to this equation. Sometimes you'll get really nice results like that. Other times, they're not going to look quite so nice. So let's take a look at another example here. So in this case, we'll have 2x squared is equal to 10x minus 3. Now, when we take a look at this example, what we may notice is that this equation doesn't have the form that we're looking for. We want to make sure we're getting all our terms on one side of the equation, so the other side is equal to 0. And so what that would mean is that we would need to subtract 10x from both sides of the equation and add 3 to both sides. So that would give us 2x squared minus 10x plus 3 is equal to 0. Now we can use the quadratic formula here as well. And in this case we would have a equals 2, b is negative 10, and c is 3. So we would go forward using our quadratic formula. And we'll replace the a's with 2's, the b's with negative 10's, and the c with 3. So we'll have x is equal to negative b, that's negative 10, plus or minus, square root of. Once again, b is negative 10, we're squaring that here. And then minus 4 times a, which is 2, times c, which is 3, all over 2a, 2 times 2. So we need to simplify this. We'll have minus a negative 10, same thing as 10. And then plus or minus, square root of. Square the negative 10, you get 100. Then minus 4 times 2 times 3. Well, 4 times 2 gives us 8. 8 times 3 gives us 24. And the bottom is 2 times 2, which is 4. Now, we'll definitely want to simplify this. And so we'll have x is 10 plus or minus. And then square root of 100 minus 24, square root of 76. But if you remember, a very recent section, we were taking a look at how to represent things like square root of 76 a little bit differently, simplify them. And so when you think about square root of 76, you want to ask the question, what's the largest perfect square that divides into 76? And what we recognize is that square root of 76 is the same thing as the square root of 4 times 19. And when we take a look at our rules for square roots here, we know that's the same thing as the square root of 4 times the square root of 19, or 2 times the square root of 19. So the square root of 76 can get replaced with 2 times the square root of 19. Now, that means x is the same thing as 10 plus or minus, and once again, square root of 76 is 2 times square root of 19. So we have x is 10 plus or minus 2 times the square root of 19 divided by 4. Now if you notice, 2 is going to divide evenly into both of these pieces. So we can factor a 2 out. You factor a 2 out of 10, you get 5. Of a plus or minus. You can factor a 2 out of 2 times square root of 19, and you get square root of 19. The 2 over 4 reduces down to a 1 over 2, and so that means we get x is 5 plus or minus the square root of 19 divided by 2. Now this gives us two answers. We have 5 plus square root of 19 divided by 2, and 5 minus square root of 19 divided by 2. All right. Now let's take a look at the next example here. So we're going to solve a half x squared minus 5/4 x is equal to 3 halves. Now, it probably doesn't look very good at this point, but one thing we can do is get rid of these denominators. You got 2, 4, and 2 as our denominators here. But if we want to get rid of them, we could very easily multiply both sides of the equation by 4. And so if we take 4 times half x squared minus 5/4 x, that'll equal 4 times 3 halves. So we'll have 4 times a half x squared. 4 times a half is 2. So we'll have a 2x squared. 4 times a negative 5/4 is a negative 5. So we'll have a negative 5x. And then 4 times 3 halves. Well, think of it as 4 over 1 times 3 over 2. 4 times 3 gives you 12 up top. 1 times 2 gives you 2 on the bottom. 12 over 2, same thing as 6. Now, I don't exactly have the form that I want right now. I want to make sure that all my terms are on one side of the equation, so I'll have 2x squared minus 5x minus 6 is equal to 0. Just subtract 6 from both sides of this equation. And now I do have the form that I'm looking for, because I know now that a is 2, b is negative 5, and c is negative 6. So I can use the quadratic formula and get the answer that way. So we'll take a look at quadratic formula again. And we'll plug in 2 for A, negative 5 for B, and negative 6 for C. So negative B, negative 5, and plus or minus square root of negative 5 raised to the second power minus 4 times A, which is 2, times C, which is negative 6. All over 2 times A, all over 2 times 2. Now we're going to want to simplify this, because it doesn't look very good right now. But your minus a negative 5 gives you 5. Plus or minus. Square the negative 5, you get 25. You have a negative 4 times 2 gives you a negative 8. Negative 8 times negative 6 gives you a positive 48. And then the bottom, 2 times 2 gives you 4. Now underneath the radical, we have a 25 plus 48. So x is 5 plus or minus square root of 73 divided by 4. But we're not going to be able to take any, or not going to be able to divide any perfect squares into 73 to simplify this. So this is what we're stuck with. 5 plus square root of 73 divided by 4. And 5 minus square root of 73 divided by 4 are our two answers here. And sometimes it works out that way. Now I got one more example I'd like to show you. And here we're going to find the x-intercepts of the parabola. F of x equals 6x squared plus 3x minus 2. So when we go to solve this, we're being asked to figure out the x-intercepts of this parabola. But remember, to find the x-intercepts, you want to set y equal to 0 and solve for x. Well, y is our f of x here, so we'll set f of x equal to 0 and solve for x. And so that means we're going to get 0 is equal to 6x squared plus 3x minus 2. Or 6x squared plus 3x minus 2 equals 0. We can write it that way, of course. And if we do, notice that we have a is 6. We also have b is 3, and we have c is negative 2. So one more time, we'll use the quadratic formula. So we have negative b, that's going to be negative 3, plus or minus square root of b squared, that's the square root of 3 squared, minus 4 times a, which is 6, times c, which is negative 2, all over 2a, well, that's all over 2 times 6. Now we're going to want to simplify this. So we'll get x is equal to negative 3 plus or minus square root of. Now your 3 squared gives you 9. And then we have a negative 4 times 6 is negative 24. Negative 24 times negative 2, positive 48. Bottom is 2 times 6, which is 12. So it turns out that we need to add the 9 and the 48 underneath the radical. We'll have x is negative 3 plus or minus square root of 57 divided by 12. And so you might ask the question, well, can we simplify this square root of 57? But if you think about it, 57 is 3 times 19. And, well, 3 is prime and so is 19, so we're not going to be able to take out any sort of perfect square from 57 that's going to help us simplify this. So this is what we're stuck with. But remember, we're being asked to figure out the x-intercepts of the parabola. So our x-intercepts are -3 plus square root of 57 over 12, comma 0, and -3 minus square root of 57 over 12, comma 0. So not the nicest looking answers in the world, but they work, so that makes us happy. Now, if you think about all the examples that I showed you so far, when we take a look at what's underneath the radical is b squared minus 4ac, every single time we got something that was positive. Now, that just happened to be the case because of the examples that we looked at. But that's not going to be the case for every possible example. Sometimes your b squared minus 4ac is equal to 0, and sometimes the b squared minus 4ac is negative. And if we take b squared minus 4ac as negative, this quadratic formula is going to give us a square root of a negative number, which means we're not going to have any real solutions for x. And so this last part that we're going to be taking a look at involves what's called the discriminant. And so for this definition, for the quadratic equation, we have ax squared plus bx plus c equals 0. The discriminant is b squared minus 4ac. Now, this discriminant is going to give us some information regarding the types of solutions we should expect when we use the quadratic formula. Or, in general, the types of solutions we should expect when we have a quadratic equation like this. So the discriminant, once again, b squared minus 4ac is that expression that's underneath the radical in the quadratic formula. Now, if b squared minus 4ac is greater than 0, we have two distinct real solutions. If you take a look at the example that was finished off here, b squared minus 4ac was 73. We ended up getting two real solutions there. 5 plus square root of 73 over 4, and 5 minus square root of 73 divided by 4. Here, we got two real solutions. 57, that was your discriminant, positive. Two distinct real solutions. -3 plus square root of 57 divided by 12. -3 minus square root of 57 divided by 12. But there is the possibility that b squared minus 4ac is equal to 0. And if that's the case, we have one real number solution. Because imagine what would have happened if instead of 57 we had 0 here. We'd have -3 plus 0 over 12. We'd have -3 minus 0 over 12. Now, both of those would have reduced down to the same number. So we really just get two copies of the same real number solution in that case. And then finally, if b squared minus 4ac is less than 0, we have no real solution. And that would be because we would have the square root of a negative number here, and that's not a real number. So we would get what are called two imaginary solutions instead of real solutions. So geometrically, remember what's happening though. If we have let's say y is ax squared plus bx plus c. If we set y equal to 0, well, remember where we've seen that before. Set y equal to 0, solve for x, you're finding x-intercepts. So if I set y equal to 0 here, I've got precisely this equation. So if our b squared minus 4ac is positive, the two distinct real solutions will correspond to two distinct x-intercepts. If b squared minus 4ac is equal to 0, that would correspond to one x-intercept. And if b squared minus 4ac is less than 0, we wouldn't have any x-intercepts. So if I have a graph that, let's say, looks like this, then I would know that the discriminant is positive, because I would have two distinct real solutions corresponding to these two x-intercepts. If I had, or we could have the parabola opening downward but still crossing the x-axis in two different spots. If I had a situation like this, I would know that the discriminant was equal to 0, because the graph would only be touching the x-axis in one spot. And if I had a situation like this, then I would know that the discriminant would be less than 0, because there are no x-intercepts in that case. And with that, section 7.5 is finished. So let's take a look at following recommended exercises. 1, 3, 5, 15. 23, 27, 39, and 43.